What if the strong force was not a giant cosmic glue at all, but a strict repair rule that the universe refuses to break? In the energy filament theory, the strong force is how the energy C enforces one simple command: whenever three quarks are linked, it will not let you tear their tension patterns into lonely fragments. No matter how hard you pull, start again from a single quark in this picture. A quark is a tiny filament ring that drags along a straight texture which is tighter on one side and looser on the other. A built-in asymmetry that makes the ring feel twisted and uncomfortable, like a thin rubber band pinched into a crooked loop that snaps back as soon as your fingers let go. On its own, this pattern is expensive and short-lived, so a lone quark in the energy C appears briefly and then collapses into something less awkward. Only when three quarks with complementary asymmetries meet in the right orientations do their three straight textures link up into a closed triangle of bridges, so that each bridge helps to hold two rings and the three together push the composite object into a narrow low-cost stable window. That is when we stop calling them quarks in isolation and start calling the whole package a proton or a neutron, the basic bricks of matter. Now picture yourself trying to pull two of those quarks apart inside that brick. You are not gently stretching a spring. You are grabbing one of the bridges of tension between them and dragging it longer and thinner. In the language of the energy C, you are carving a sharp gap into an otherwise smooth tension field, like dragging your fingers across a tightly stretched rubber sheet until a stressed white line appears, or digging a spoon into the surface of thick yogurt to scoop out a narrow pit. The important question is not, is there a force that pulls the quarks back, but will the media tolerate leaving that kind of gap behind? The answer is no. Just as yogurt flows back to fill the pit the moment you pause, the energy C tries to refill any deficit in its tension pattern as soon as you create it. And if you keep pulling, it keeps repairing over and over, until the pattern looks smooth again. When the stretched bridge approaches a critical length where a normal material might snap, the C does something smarter with the energy you have supplied. Instead of letting the bridge tear and leaving to loose ends, it spends that energy to roll up a fresh pair of tiny rings near the wolf be broken, a new quark and a new anti-quark that appeared exactly where the gap was opening. These new rings hook into the old bridges and reconnect the tension pattern like a small patch of cloth sewn across a rip in fabric, so the crack becomes part of a new, longer chain of bridges rather than an open wound. From the outside, all of this repair work feels like an ever-growing pull. The harder you try to separate the quarks, the more the pattern tightens and the more extra structure the C creates. So it looks as if some furious invisible hands were yanking the quarks back together, when in reality almost every bit of work you do is being converted into new filament loops and fresh bridges that stop any quark from escaping alone. This is quark confinement in this picture. Quarks are not locked in a tiny metal cage and they are not covered in mystical ultra glue. Instead, the single free quark pattern is simply not a configuration the energy C accepts for more than an instant. So every attempt to pull one out triggers automatic repairs in the form of new quarks, antiquarks, pairs until all gaps are sewn shut and only bounded states remain. That is why high-energy experiments never show a lonely quark cruising through a detector. Only sprays of new hadrons built from triplets and pairs. In this sense, the strong force is less a separate kind of attraction and more a stubborn housekeeping rule. Whenever a tension hole appears, the universe immediately backfills it with new structures. So what you experience as the force gets stronger as I pull is really the media refusing to leave a rip open and never giving you the chance to walk away holding a single isolated quark. In later seasons, when we unfold the full force chapter, this geometric and tension-based picture of the strong interaction will tie neatly into nuclear binding and the behavior of atomic nuclei. But the core idea already fits in one line: strong force is not cosmic glue. It is the energy C's relentless habit of repairing every crack before it can become a tear. Tap follow, share it on New Physics, Clear Universe.